Hi, so for the parametric playground example that I took inspiration from Sou Fujimoto's Serpentine Pavilion in 2013, and as you can see how simple the idea is, but how complex it gets. So it's basically a grid, but it's melting into the nature as Sou Fujimoto's his own words. So people can come, just meet there, hang out, took pictures. There is an open air cafeteria there as well. So you see he also used some transparent elements here, but for your assignment you don't need to think that complex. You can see how a basic idea can get a very complex form. So what we're going to do, we will take this idea and then we will sort of recreate it in Grasshopper to see how we can design parametrically. So we are not going to design the same as they did here, but we sort of play around, we sort of experiment with the grid idea and then how to deform it or how to not deconstruct it, but yeah, let's say how to change it in a way that we can find some more complexity. Okay, starting to recreate the grid system that we want to have. Okay, we start sort of, okay, let me close this to be able to start from the beginning. So let's start with a point that we want to generate our system from this point. So basically defining a point on the site where I want to position my installation or playground. So you can change, you can add more points. Now we deconstruct the point in order to have another point. Okay, then I will have my planes created here because I also want to, create a sort of a rectangular prism or sort of a rectangular geometry in order to have a grid that we saw on the example. But I don't need to see the planes that I created. And just to remember, you can create more different positions on different planes. But now we don't need that. So again, closing the preview option. And then now I want to have sort of the rectangular geometry by using the rectangle component that I'm creating to rectangles. So I can just change it in different values. But for now, let's keep it like this. I want to have several of them in a grid. So, okay, let's say I use this rectangular prism, but it's open from the sides. Do I really need the top and bottom closed? Maybe you want to have it. Then you can use another component. First of all, you need to go boundary, surface. So then just by choosing your rectangles to it, and then you can really have a closed geometry and then use this one too in your prep. But in my case that I don't want to have it, just then don't need it, just use the loft geometry. So again, closing this preview, now we have the prep here, so then I can use the prep features which is that if I don't want to use the surface, but I just want to have like a wireframe kind of geometry, it means that I can generate this from the wrap component. So, okay, now I want to have several of this geometry in a grid system. For that, we need to use the array box. Since I disabled that, let's enable and see what we will have. So not very surprising. Since we want to have more complex stuff, if you remember the example that having some areas are more dense and some areas are more light in the frame, and maybe scaled versions of the rectangular prism as a gridial unit, and so on. So how we can create this kind of parametric logic? We need to reach a certain group of elements of this grid. How we can do that? If I say I want to select diagonally, like these elements, for instance, and I want to change geometry there. So then we will sort of have a mathematical expression to how to select these certain elements. So in this case, maybe I will have I want to have this element 0 and then 1, 2, 3, 4. So basically the y-axis number after that. Then I need to know the index number of this element, right? So I will have 0 here, then I will see, okay, 0, 1, 2, 3, 4, 5, and then 6. So what I want to select is the element 0 and element 6. And then I will sort of create the mathematical expression regarding to that, because this pattern always repeats this same mathematical expression in order to reach these elements. So that's why we will use some basic mathematical expressions, operations to reach certain elements. Actually, this creates a series of numbers of the indexes to choose particularly from the list of elements of the grid. So basically, if you can see the color change, so we're selecting certain indexes, and then we will have, let's see if we started from here, it goes diagonally, then it repeats itself. Sort of, you can see it starts repeating from here and then goes there. But if we have only one row, we will maybe define it more clearly. So exactly, so we have this diagonal selection, and then the other, the second row and the third row, so it goes there and then comes back here, and then yeah. Now what we are doing, we are reaching particular elements according to a pattern from a list of elements that we have. So what happens if we change the first element? Then maybe it's more clear again with the first, but only with the first row, just to show how it changed. So if we change the first element that we start, so it just shifted by 1 unit, because now we're taking this index as the first number. What happens if we change it by 2? And yeah, exactly. So this is the way how to use a series and item. Basically, series creates a list of numbers a list of index values that we want to choose from this grid. So for now, only to show how wire and pipe works and how we can create various densities on the side surfaces of rectangular prism, like a wire mesh, that I left out the other elements just to see the first selected ones, how to change wire mesh on the sides of rectangular prism. So yeah, as we can see that we play around with this idea, so we can select different groups for these elements that I want to have a certain density on the wire mesh. For that, you can select really less. So if we have 0, that means that we only have the edges. But if we want to have more, so we can add more. To give a certain thickness, we will use the pipe tool. See here that we can have it more thicker. More thicker. Or we can have it very light, thin elements. We enabled all the wire components that we have a complete grid structure with various densities in certain areas. It's more dense, as you can see. When it gets in the core, it gets more dense. On the sides, it's less. So we can also see how the thickness will appear. So let's see if we can see how the thickness will change. Level, see more definite. Okay. When you go back, actually you can change a few things that might be interesting. So remember the second point that we generated above the first point. Then we create our rectangle geometry based on that. Now we can also add some x value to it. So maybe this